Cable ident has its value, and there has to be a value to get customers to install these products. Obviously, identification of ends of terminals, connectors and cables is important to the end user in terms of maintenance and installation. If a problem occurs at one connector, you need to know where the termination would be, and Cable ident is designed to actually enable quick and efficient identification of problems. When evaluating a Cable ident product, you have to consider two things. The first is the effect of the environment on the product, such as thermal properties, fluids, UV, etc., and how they will affect your ability to read the mark and the mark to be where you put it, i.e. location. But another important consideration is the effect of the product on the environment, such that if you have any corrosive ingredients coming off at high temperatures, whether they affect copper or anything delicate within the environment. Fire situation is an important consideration as well. This is obviously a failure mode of the environment, not the product, but if in a fire situation you have to consider what the product will contribute to the hazards of that situation. In situations such as enclosed cabins, in trains, in planes, and areas where close proximity to humans in the fire situation can cause problems by anything eliminated by our product, we then have to take a different approach, which is where the term low fire hazard comes to in TE. Fire ignition and fire propagation can be controlled with the addition of standard flame retardants. Halogens and the like are often used. But I always think of these as being the same situation of trying to burn a damp bonfire, where you try and give inefficient burning, and inefficient burning always produces lots of smoke, not much flame, but lots of smoke and lots of toxic materials. In other situations where there are people in close proximity or in closed spaces, this poor burning effect of producing toxic smoke and gases can be a problem. So what you need to do there is to make sure that what you do produce from retarding the ignition does not contribute to the dangers of the hazard. Okay, in TE world, we've over many years developed low fire hazard products. True low fire hazard products in our definition are normally based on highly filled systems. Highly filled systems tend to give you the flame retardancy properties we're looking for and the low fire hazard properties, but we do tend to compromise on physical properties and fluid resistance. The future, as in all situations, seems to be the environment is getting more and more harsh. So what we're looking for now is the same flame retardancy and low fire hazard properties, but with increased resistance to the environment, i.e. higher temperature, higher fluid resistance and better physical properties.